Hello everyone. Our today's question is related to the gravitational force. So let us read the question. What is the question? Two solid spheres of the same size of a certain metal are placed in contact with each other. Prove that the gravitational force between them is directly proportional to the force power of their radius. As the two spheres of the same mass m and the same radius are in contact, and we have to prove that according to the question, the gravitational force between these two spheres is directly proportional to the force power of the radius of each sphere. So normally, according to the Newton's law of gravitation, we know that the gravitational force between the two objects is directly proportional to the inversely proportional to the square of the distance between them. But here we have to prove it is directly proportional to the force power of the radius of each sphere. So let me apply the formula of gravitational force. So the force between two masses is given by the formula G m1 m2 upon r square. You already know that where G is the universal gravitational constant, m1 and m2 are the masses of the object. In between them the force is required, and r is the distance between them. So, but we have to prove that this force is directly proportional to the force power of the radius of these two spheres. So, let me put the value G, M1 and M2 both have the same equals to the M according to the figure. So M1 is M, M2 is M, so it must be M square and upon. Now, see from the figure, the distance of each sphere is R, so distance between them is 2R equals to the sum of the radius of both the sphere. So distance between the center of both sphere is 2r. So now here at the place of r we have to put 2r. So this is 2r and now gm square by 4r square. So this is the gravitational force between these two spheres. But we have to prove the force is directly proportional to the force power of this radius. So what we have to do? So we already know that if both the spheres are of the same material, so if their density is rho, so the density is always given by the mass upon volume. So if the density is rho, then the mass is equals to rho into V, and the volume of any spherical body is given by 4 upon 3 pi r cube. So this rho volume replaced by 4 upon 3 pi, and radius of each sphere is this. So the mass must be equals to this, rho 4 by 3 pi r cube. Now put this value of mass m in this. We have F equals to G, m is replaced by rho 4 by 3 pi r cube square divided by 4 r square. So you can see this is G into rho square, 4 square means 16, 3 square means 9, pi square, r cube square means r to the power 6 divided by 4 r square. So that's now it is 4 by 9 G rho square pi square r square is this, r to the power 6 is this, r to the power 4 is here. So the gravitational force between these two spheres is F equals to 4 by 9 G rho square pi square r to the power 4. So clearly 4 by 9 G rho pi. These are all the constant. So because this term 4 by 9 G rho square pi square is a constant. Therefore, F must be directly proportional to r to the power 4. We require this according to the demand of question. The gravitational force between these two spheres is directly proportional to the force power of the radius of each sphere. Okay, that's all.